Video lectures and ISR initiative by Shivanand Sharma Memorial RV College. SSMRV College is one of the premier institutes run by the prestigious RV group of institutions, has come up with a unique initiative to engage students at the time of this unforeseen medical emergency caused by corona outbreak. As a socially responsible institution, we would like to connect academically with students to make good the losses caused. In this connection, I, Mrs.Bharati Rathod of Department of Computer Application, has posted a video on the subject system programming and the topic is structure of compiler. Please watch the video till the end and like, share with your peer groups and subscribe to our YouTube channel. Compilers. Compiler is a system software which accepts program which is written in high level language and produce an object program. Consider block diagram of compiler. Here source program is high level language and compiler converts into object program. The compilation process consisting of first loading the computer with the compiler and then inputting the source program through suitable device. The compiler produces an object program which is saved on the storage device. Compiler is a standard program written and supplied by a computer. During compilation process, it checks each coded instruction to see that it follows the grammar for that language and uses proper spelling and syntax. All acceptable instructions are translated into machine language and stored. In case of error in the program, it communicates through messages. This message will appear on the output screen of a program listing. The program can be executed only when it is found error-free. Design and writing a compiler is more complex as each source program instruction in a high-level language generates a number of machine code instructions. Also, compiler occupies more storage space and takes more processing time than assembler. Structure of a compiler. General model of compiler. Consider PLI program which is taken as an example to explain the overall task performed by the compiler. Here, calculate is used as a label, procedure is keyword and equal to is operator. We have first statement which is procedure with 3 arguments, second statement which defines 4 variables of fixed binary numbers of 31 bits. In third statement is assignment statement that performs arithmetic operation. Fourth statement is a return statement with 1 argument. Compiler must perform the following 4 functions. Recognize certain strings as basic elements or token, that is variables, operators, keyword, etc. Recognize combinations of elements as synthetic units and interpret their meaning. Allocate and assign location for all variables in the program. Generate the appropriate object code. Problem 1. Recognize basic elements or tokens. The source program is scanned sequentially and broken into pieces or blocks are called basic elements or tokens. Tokens are recognized as identifiers, literals or constant, terminal symbols, operators or keyword. Consider above example. Here, identifiers are WMC, rate, start, finish. And keywords are recognized as procedure and terminal symbols are colon, semicolon and comma. Lexical analysis. The action of parsing the source program into The proper syntactic classes is known as lexical analysis. The basic elements are entered into the table as the information of basic elements are required by other phases of compiler. This information of the tokens are entered with the data type, length, storage class, etc. We have classes of uniform symbols are identifiers, terminal symbol and literal. Consider first statement of example program. We will have uniform symbol of first statement. Here we have identifiers as WMC, rate, start and finish. And terminals are colon, open bracket, close bracket, semicolon as well as comma. Problem 2. Recognizing syntactic units and interpreting their meaning. Once the program is broken down into tokens or uniform symbols, the compiler must perform two separate tasks: recognizing the phrases and interpreting their meaning. In case of recognize the phrases or statement, the compiler checks for the validity of each statement. If statements are free of errors, then statement is declared as valid. Or the compiler assures some sort of recovery and continues with the compilation error of next statement. Interpreting the meaning of construction. After performing the above step, the resultant form is called a syntactic form or semantic form. Example, valid procedure statement means the syntax of the statement is checked first and the meaning of the statement is defined in the second step. Hence, syntax analysis is defined as the process of recognizing and separating the basic syntactical construct and interpreting their meaning. Each syntactic construction is associated with defined meaning. Syntactic constructs are reduction, action routines. In reduction, they have rules that specify the syntax form of the source language. In action routines, after defining syntactic construction by the reductions, appropriate compile routines or action routines are executed when construction is recognized. Step 3. Intermediate form. The process of generating the object code for each construction after determining syntactic construction is known as intermediate form. It depends on syntactic construction. They are arithmetic statement, non-arithmetic statement and non-executable statement. Arithmetic statements. One intermediate form of the arithmetic statement is parse tree. The rules for arithmetic statement into a parse tree are: any variable is a terminal node of a tree. For every operator having two branches in a binary tree, whose left branch in the tree for operand 1 and right branch in the tree is for operand true. Priority to constrain the tree. Highest priority is given to the expression written in the brackets. Multiplication and division operator having second priority. Addition and subtraction operator having third. If the sequence of the operator is same, then start solving from left to right. Consider expression x equal to y plus z, which is represented by parse tree. Here, for every operand required to construct a binary tree whose left branch is the tree for operand 1, that is y, and right branch is for operand 2, that is z. Non-arithmetic statements such as do, if, go to. are some example of non-arithmetic statements. These statements can all be replaced by sequential ordering of individual matrix entry. Example, matrix for return and end statement. Here, operator return and operator 1 is cost and end is the operator. Non-executable statements. Non-executable statements such as declare give the compiler information that clarifies the reference or allocation of variables and associated storage. This information contains in a non-executable statement is entered into tables. Consider below declare statement. Here variables are cost, rate, start and finish. Data types are fixed binary of 31 bits and storage class is static. Problem 3, storage allocation. Storage allocation is done at the time of compilation. Only static storage class can give the details of the entry in the identifier table like pace, scale, precision and then reserve the proper amount of storage. Types of storage classes are static, automatic, controlled and based. In static storage class, it is default storage class for externally compiled subroutines and main programs. A variable that is declared static has the memory location fixed only for itself. In case of automatic storage class, used for variables in a procedure that will not be retained once the procedure is over. In controlled type of storage class, it is used for common block variables. If a common block variable is initialized, the whole block resides in the data storage area. Controlled variables are protected against being used in ways that may cause interference. In case of based, these cannot be assigned the same way as static storage class. The object code is generated for the statements such as procedure, begin and allocate by the compiler. Similarly, end and return statement must generate object code to free the dynamic storage for future use. Accessing dynamic storage is difficult. References to this type of data may be made relative to register that can be updated at execution time to point at the dynamically allocated data. Problem 4, code generation. The code generation phase taking the input in the matrix form and generating the object code for each and every entry defined in the table. It also uses macro definitions which defines operators to produce. We have one example, start minus finish. In the above statement, the operator minus in the matrix is treated as macro call. The operands start and finish is treated as macro arguments. Now, for minus operator, the standard code is load, subtract and store. Load operand 1 in register 1, subtract register 1 with operand 2 and store content of register 1 in the line number of matrix entry. The following code can be generated. The above statement using code definition of the operator minus is load the operand start, subtract start with finish, store in the matrix line number M1. Now we have the following code which can be generated the above statement using code definition of the operator minus, add, multiply and equal. Now we will have code for minus, load content of operand 1 into register 1, subtract content of register 1 with operand 2 and store the content of register 1. Similarly, for addition, load operand 1 into register 1, add register 1 content with operand 2 and store. Similarly, for multiplication, load, multiply and store equal to load operand 2 in register 1 and store it in the operand 1, where ampersand operand 1 is the first operand of the matrix and ampersand operand 2 is the second operand and ampersand n is the line number of the matrix entry being examined. Optimization, machine independent, removing or deleting the duplicate entries in the matrix and modifying all references to the deleted entries is one type of machine independent optimization. Consider a table with common sub-expression and matrix after elimination of common sub-expression. When a sub-expression occurs in the same statement more than once, in common sub-expressions like start minus finish, which is occurring 2 times, the duplicate entries can be deleted in the matrix and can be modified as shown in matrix after elimination of common sub-expression table. Machine dependent optimization. This phase has reduced both the memory space and execution time of object program. Since these two factors is dependent on machine, this type of optimization is known as machine dependent optimization. Assembly phase. The code generating phase is producing assembly language or process of generating the actual code is known as assembly phase. Hence, we can define assembly phase as process of generating the actual code. The assembly phase must perform these operations: resolve label references, calculate addresses, generate binary machine instructions, generate storage, convert. General model of compiler. In analyzing the compilation process, there are 7 distinct logical problems are as follows: lexical analysis, syntax analysis, interpretation, machine independent optimization, storage assignment, code generation, assembly and output. Lexical analysis is recognition of basic elements or tokens and creation of uniform symbols. In case of syntax analysis, recognition of basic syntactic construct through reductions. In interpretation, define exact meaning, creation of matrix and tables by action routines. In machine independent optimization, create optimal matrix. The phases from 1 to 4 is machine independent and language dependent because the phases helps in determining the syntax and meaning of each statement in the source program. Hence, it is dependent on language and independent of machine. Let us see fifth phase, that is storage assignment, modification of identifier and literal tables. It makes entries in the matrix that allow code generation to create code and allocates dynamic storage and also allows the assembly phase to reserve the proper amount of static storage. Code generation. A macroprocessor is used to produce more optimal assembly code. Assembly and output resolves symbolic addresses and generates a machine language. Phases from 5th to 7th is machine dependent and language independent because these phases allocates memory space for literals and also generates assembly code which is dependent on machine. Hence, it is not dependent on language. Let us see the diagram of structure of a compiler. Now, we will study about the databases used by a compiler which forms the lines of communication between the phases. Source code. The user program is the source code. Uniform symbol table. It consists of full or partial list of tokens as they appear in the program created by lexical analysis phase and given as input to syntax analysis and interpretation phase. Terminal table. A permanent table which lists all keywords and special symbols of the language in symbolic form. Identifier table. It contains all variables in the program and temporary storage and any information needed to reference or allocate storage for them. This table is created by lexical analysis, modified by interpretation and storage allocation, and it is referenced by code generation and assembly phase. Literal table. It contains all constants of the program. Reduction. It is a permanent table of decision rules in the form of patterns for matching with the uniform symbol table to discover this syntactic structure. Matrix. It is created by intermediate form of a program which is in turn created by the action routines. It is optimized and then used for code generation. Code productions. It is permanent table of definition. There is only one entry defining code for each matrix operator. Assembly code. Assembly language version of the program which is created by code generation phase and it is input to assembly phase. Relocatable object code. The final output of assembly phase. It is ready to used as input to loader. Thank you for watching.